Hi, so I'm Neville Swade. I'm representing the Access program in the CSIR, and I'm just presenting these slides for a record of our meetings. So what I want to talk about is really these 5 items that to make the point that climate change is no longer of the future. It's something which is now manifesting. Climate change does not happen on average, both in time and space. That seasons really matter. Extreme events are the currency of climate change. And I want to talk a little bit about El Nino 2023. And why I want to talk to this is really about delivering climate services to different sectors at the right time and space scales for different applications. And I'll get back to this a bit later on. But to start with, I want to just make the point that climate change is now no longer something of the future. It has really arrived. And I'm starting to ask the question, are we at a tipping point? And how would we know if we're at a tipping point? Do we expect a tipping point to be something which happens from one day to the next, or one season to the next, or 1 year to the next, or 1 decade to the next? How will we know? But I would argue that 2023 is really testing us in this regard. What I'm showing you here is some data from climateanalyzer.org, which basically gives us the 2-meter air temperatures around the world, at average temperature, just to illustrate change. And what you're looking at, the stippled line in the middle, is the long-term average, and the 2 lines above and below are the 2 standard deviations away from that average. And I'm illustrating here the year 1993, where this record, near the beginning of this record, showing you what a typical year looks like. It's always warmer in the summer months, mostly because of the fact that the Northern Hemisphere has more land. So that's the Northern Hemisphere summer, June, July, August. Those are the warm months globally because of that phenomenon. So that's 1983. Then in the next slide, I've still kept 1983, but I've also included 2003, just to show that there is gradual warming of the atmosphere on this record. As you can see, this is now towards the extreme of that long-term variability. And then I've included just last year, and that was a La Nina year, where I'll talk about the next, ocean temperatures in the Pacific were below average in the El Nino region, but still that year's air temperatures were quite high relative to that long-term average, and hitting new records. And then here is 2023. So you'll see 2023 is really a different kind of year, and this puts us into a new record, really. We are seeing the warmest day ever recorded on Earth, the 6th of July, and July being the warmest month ever recorded along this time series of data. So really seeing significant warming, and I'll talk about the impacts of that in a moment. This is just a chart also from another website, Council on Foreign Relations, NAT data, showing the distribution of the departure from long-term average, 1951 to 1980, long-term average of temperatures. And you'll see 2 points here. One is that the contribution to this average is not even. So certain parts of the world are warmer than others, and that's to make the point that climate change does not happen on average. It happens in very different timescales, and some places are even below normal. But on average, it's the warmest month ever recorded. That's that point. Then I want to move to the oceans. And here, similarly, I'm displaying some data from Climate Analyzer, which shows the long-term sea surface temperatures, the skin temperature of the oceans. And here you see the long-term average, which fluctuates over the months, and the 2 standard deviations. And I've included the years 1983 and 1993 at the bottom, the light colors, as well as December 2003, also to show the fact your increase in the average temperatures over time, over this record. And the point I want to make here is that the oceans are warming at a faster rate than the atmosphere. And you'll see why that's important in a minute. And then I've included a couple of other years, also retained the others for reference. But 2015-16 was an El Nino year, and those two traces under the orange is showing that that El Nino year put us into new sea surface temperature records in that year. Really special El Nino, deep El Nino. And 2022 in the orange is in fact a La Nina year, but still exceeding the 2 standard deviations above the long-term average. And now let's look at 2023. So those are the sea surface temperatures of long-term, relative to the long-term average in 2023, really in new territory. And I guess what I need to stress here is to take-home message is that the atmosphere is warming at a slower rate than it could or should, because the oceans are absorbing the heat and warming at a faster rate. And I need to stress that's at all depths. Now we are seeing new records. Every year we're seeing new records. And effectively, I would argue, we are living in a different planet to the one we were living in 20 years ago. And of course, there are consequences to that. So this year we have an El Nino, which I'll talk about later, and it's an extensive El Nino. That heat that's being absorbed, the global warming that's being absorbed mostly by the oceans, is now being released into the atmosphere through this phenomenon of the warmer sea surface temperatures. And so we're seeing temperature records around the world. And the consequences, again, I need to stress, are distributed in space and time. And so we see a well-documented increase in both the frequency and the strength of extreme climate events. As the UN Secretary General has put it, this summer, this is the Northern Hemisphere summer, the boreal summer. The dog days of summer are not just barking, they are biting. Climate breakdown has begun. And here's a record of the Canadian wildfires. There were wildfires in other parts of the world, like in Hawaii and in Chile, which we've seen are quite unprecedented flooding, even cooler temperatures than normal for this time of year. Record flooding pretty much everywhere in the world. This big Libyan event that happened last week or the week before, also a man-made problem, but exacerbated by unprecedented rainfall issues there, and in various parts of the world. You can look up how 2023 is shaping up to be a really special year. And I looked at some data from Swiss Reinsurance. Now, what they provide is they do an analysis of the cost of impact in terms of US billions, both in terms of the actual costs as recorded or by the insured loss. But this summarizes a very interesting record, and you'll see they've looked at global catastrophes, separated out weather-related from earthquakes, and you will see the trend. So we're seeing more and more weather-related impacts in terms of loss. Now, whether that's because there's better data or because there's more that's built in harm's way, it's hard to separate out, but certainly the costs of these extreme events are rising. That's up to 2022. And in fact, it's very interesting. I just kept the same graph there because it's slightly older data, but it identifies the kinds of events. So what's really going up are the hurricane impacts, Hurricane Harvey, Irma, and Maria, Thailand floods, Japan floods, hasn't even got the Pakistan floods on here. So that's just to show you that there is really an intensification as well as actual costs of these extreme events. So so this is to stress the point that we're really in a different place now. Whether we can consider this a step change or a tipping point needs to be considered. And I want to stress the point that climate change does not happen on average. And so different parts of the world are warming at different rates. The impacts on seasons are obviously very different, and seasonal zones, climate zones are also changing. And that really, the key point is that what climate change is bringing is more variability, not just a unidirectional trend, but also more extremes on both ends of the scale. Drier, wetter, cooler, hotter. We have these enormous cold events, cold snaps in North America, also associated with climate change. And these two charts just just show the trends are different in different parts of the world. Now, I want to talk about the seasons and extreme events next, and why do the seasons matter? And I'd like to use this chart over here. And here you will see long-term variability in the green line. Those show you the seasons, and the seasons are always different. This season is the same as any other. It might be shorter, might be longer, might be colder, wetter, drier than normal, but we still see our effects of summer and winter, especially in the very seasonal high latitude areas, less on the equators. And so that's a signal. It's a steady signal, but it's a noisy signal. Below that are extreme events, and extreme events happen, and they happen naturally. A confluence of climate configurations, a particular set will create conditions for different kinds of extreme events, against floods, droughts, etc., etc. And they happen with a particular return period, and they are something which is part of the natural system. The blue line is the long-term average change to climate. And if we combine those three together, we get the black line. And in the black line, you can still see the seasons. So we still have summer and winter under different scenarios. But the extreme events now are on the rise, the impacts, at least the records, because they are on a higher baseline platform. So we in summer with a warmer than normal summer, we put an extreme event on top of that that pushes us into new records. And again, with the repetition of these events, we don't have time to recover, and they can cause long-term, if not permanent, damage. And survivable extremes really refers to biological populations and ecosystems. But I think the key point here is that this illustrates why seasons are so important. What kinds of summers are we having? What kind of winters are we having? What's happening with extreme events in frequency of extreme events, and why they're becoming more intense is really, really important. And so why is extreme events important? Well, if we look at this theoretical oscillating line here, let's just assume that's temperature, or it could be rainfall, or it could be flooding or drought, or any other parameter you want. But basically we have seasonality, and this is an ideal scenario, winter and summer recurring regularly. And we are used to a certain level of variability. So we have a tolerance threshold. We are used to certain kinds of summers, certain kinds of winters, depending on where we live, and our lives are adapted accordingly. If you're poor, the impact of even normal or traditional or long-term or average variability is difficult to deal with. Very hot days, you don't have cooling, very cold weather, very wet weather. You don't have the resources that might be needed to cope with even that kind of variability. But if we push beyond that point to extreme events, consider these little blue triangles as extreme events, which take us beyond that threshold of tolerance. So here we start to see damage to the environment, or damage to infrastructure, or damage to resources caused by an extreme event. Of could be a heat wave, could be flooding, could be a drought, as the case may be. And our level of tolerance is then maladapted to that extreme event. And if you're poorer, the impact on you is even greater. And then at the bottom panel, really, if we start to see that global change drivers start to exacerbate this is where human-induced impacts occur, such as a dam bursting, the canalization of rivers, or the mismanagement of runoff, as we might have seen in Durban. So the impacts, or the overcrowding of people, or the suitable housing, etc., makes us more vulnerable. And so the impact of that climate extreme is even greater. Okay, so that illustrates why extreme events and seasons are really important. Okay, next slide. Okay, just going to go here. And I want to just talk about what we know about El Nino at this juncture, which is in mid-September 2023. And at the top right, that chart, which I hope I'll be able to show you here, this talks about the areas at which we look at the indices of the development of El Nino. So there's El Nino Area 4, El Nino Area 3, and 3.4. And this is just to show, well, in the last 50 years, since 1950, the last 80 years, the top 8 El Ninos in terms of strength, in other words, departures from average, El Nino 3 and El Nino 4, will show you that this year's El Nino is not the worst one. In El Nino 4, it's tending towards an extreme event, an extreme El Nino, and El Nino is an extreme event by definition, but as El Ninos go, it's not the worst one we've had. It's a bit early to tell what the impact will be later in the year, and we've had worse ones, but it's an extensive one, so the area that is showing change matters, and so this brings that heat of the oceans to the surface, where it can be absorbed by the atmosphere, or go back into the atmosphere and create changes to global circulation. However, El Nino is not the only phenomenon. In the Indian Ocean, there's the Indian Ocean dipole, which is a similar type of scenario. Has different phases. As you can see on this red line, there's a positive and negative phase. And it is now in a positive phase. And when there's a positive phase, it generally tends to promote rainfall in the Southern African region, central to Southern African region. And so our climate models that are used to assess the climate system and make projections about the coming season are a little indecisive at this stage. And I want to stress this. This is a multi-model probability forecast for precipitation December, January, and February 2024, issued in August. And it is saying that there's a slight probability of a drier Southern Africa, a wetter East Africa. However, stress that the confidence, the certainty and confidence that we have around this projection is low relative to what it normally is. Okay, so you will see mixed signals. Some models are producing a projection of a wetter than normal season, some a drier than normal season. And so we get a consensus out of multi-models, but the confidence is low in terms of precipitation. So we don't know, because there are different opposing forces influencing this season's climate. Around temperature, there's a bit more confidence of a warmer than normal season. Generally in El Nino, there's a drier, warmer than average season. We've had 2015-16, which really had a big impact, El Nino 2015-16, but the El Nino of 1997-98 was a very strong El Nino, but it actually had ordinary, almost normal average rainfall. And so it's very difficult for us to tell at this stage, but we're busy working on that. Obviously, we're monitoring very closely. And so why is this important? Again, I stress, it's important because climate scientists need to know what products to develop and produce for various sectors in our society who need to use this information. And that's where your role is important. If you're in health, if you're in water management, whichever particular sector you work in, it's critical that we have a conversation through this user interface platform on the left. We have the conversation ongoing to understand what your needs are, and for you to understand what we as climate scientists can produce to ensure that the products out of the observations and the modeling and the information we develop out of that is useful to you, and that is specified at the scales that you need them. And that brings us to the outlook on the right. Really what we're heading towards is to try and develop a system which is looks at different time and space scales. It's kind of seamless in those senses. We need to be able to produce information that is useful to you on the operational level, where it's matters of days, hours, minutes, even weeks. At the tactical level, which is at weeks to months to seasons, and at the strategic level, which is at years to decades. And we have to understand that because climate change has manifested in the form of changing seasons and extreme events, these timescales are integrated. And so it's critical that we have this conversation, an ongoing conversation, so that we can provide the right science to apply in the different fields. Okay, I'm just going to finish off by a reminder of the Access website. And for those who are still interested, we have these two developing research alliances. One is called REACH, the other is called the ECERA or ECERA, One is looking at climate and health, the other at extreme climate events. So please visit those. And then to alert you to two events or two things that are happening. One is our event at the end of the year where we're going to have with the South African Association for Atmospheric Sciences, we are holding a workshop on extreme climate events and on climate and health. You can get more information on our website and, very importantly, on our survey around climate and health and extreme events, which we would want all interested people to participate in. And with that, I will end and thank you.